Good morning, everyone, and welcome to this morning's webinar. What we're going to be covering here this morning is going to be improvements to the BIM joist in SDS2. So we did a webinar quite some time back on the BIM joist when it was very first released, and we've added some good functionality here just recently that we wanted to cover and get everybody a little bit familiar with. So the two things that I'm going to be covering here today is going to be, first off, we now have a pre-configured panel joist that we can input into the model rather than just the typical reserved space where it gives you one big chunk of material and you don't actually see the web layout and the web panel of the joist. We now will be able to do a pre-configured layout to see that. The second part of this is going to be connections. So we've actually added some connections to the BIM joist. A lot of it we've been able to do with just the regular joist member in the past, but this does give us some additional functionality and pretty much everything that we could do with the regular joist we can do now with the BIM joist plus some, and gives us a little bit more flexibility with that. So those are the two things I'm going to be covering. Like I said, keep in mind these two enhancements were added to the BIM joist in version 7.318. I'm using version 7.320 today, so to get this, like I said, you'll need to be at least in version 7.318. So I'm going to go ahead here, just have our simple basic training model. I've kind of taken some members out here where I'm going to be adding the BIM joist to show us this functionality. So I'm going to start off with a pre-configured panel layout, and a few things just to mention with the pre-configured panel layout before I start inputting. You need to start communication between Vulcraft and yourself at the very beginning of your project so that they know you're going to be using the pre-configured panel layout in your model, and they can do the coordination on their end. That's going to allow for earlier coordination with other trades. So that being said, I'm going to go ahead and just zoom in here. I have a little mezzanine here where I'll input some joists. So I'm going to first off go into my plan view that I have here. I'm going to add a few construction lines, and I'm just going to do a base member line, and I'm going to add these at 3 foot apart. And I'm just going to add joists in here. Now, with the BIM joist, we actually have a couple different options as far as how we're going to input those. I'm going to begin by inputting these joists at the top of the joist, where I have to account for the bearing seat or the bearing depth, just like I would the regular SDS2 joist. So to add a BIM joist, I'm going to hit the F2 on my keyboard to bring up my member type selection, and I should have a BIM joist in there. I'll go ahead and select that. And since I want this to be, I'm going to put in just a K-series joist, so the seat depth is going to be 2.5 inches. So use an intersection construction line and member for my point locator. I'm going to also combine that with my offset controls down here at the bottom of the screen. So I'll put in there 2.5, and I'll go ahead and pick my 2 points there. I get my BIM joist window up. First thing I'm going to do is pick my section size here. I could go ahead and hit the browse, or I know I just want a 10K1, so I'll go ahead and type that in there. You got your sequence, a shape. We're really going to just mostly be dealing with just a parallel shape joist here. The other thing you're going to notice is over here on the right-hand side, you have a bearing condition. So this allows us to actually change kind of how we're inputting this. The TC bearing option would input this joist. The 2 points that I picked would be the bottom of my seat, or like I said, I'm going to input it. TC bearing flush is the top of the joist. Okay, so I'm going to first start off. That's all I'm going to change here. Just pick my section size, my bearing condition, and I'll hit OK. I'll just return out of that, and I do need to process and create solids. So I'll run through that. And what I'm going to see here is you see just the typical reserved space joist that we've always typically seen. Doesn't actually give you the web material or anything, just a basic idea of that. So I'm going to go ahead and hit my F2 again for the BIM joist just to show you that I can go in here and I can middle click to use my repeat just like I could with a beam if I were inputting a beam. So very similar in that case. Okay, so now I got 4 identical joists in there, and next thing I want to do, I want to show you the pre-configured panel layout. So just to show you some additional functionality, I can do a multi-edit with my joist. So if I right-click on top that one and go to Edit Other, I have all 4J_80, and it's going to do a multi-edit on those. Okay, so what I need to do for the pre-configured panel layout is I just need to simply check this new BIM Vulcraft checkbox here. When I do that, I am going to get kind of a disclaimer in here, and the reason I need this, why Vulcraft has this in here, is these pre-configured panel layouts are going to be sufficient unless there's project-specific design or loading conditions that might require those joists to be engineered a little bit differently. So just a disclaimer on that. The other thing you're going to see in here is that the pre-configured panel layout uses kind of a worst-case scenario as far as the size of materials that's used to create these in the model. So just another part of that disclaimer. And I do have to check that box to say I have read and agreed to these terms and conditions. You should only see that once per modeling session. So if I input joists on later and use that, I'm not going to see that come up every time. So kind of what's going on there. So I just simply check that. That's all I'm going to do here for now. Go ahead and say OK. And now when I process and create solids, I'm going to see, instead of just that reserved space joist, I'm going to actually see a pre-configured layout there with my web material then. Okay. We'll go ahead and just snap to the surface here of this so we can see it from the side. And now let's say on this particular one, just some different things we can do here. Maybe I want some extensions on each end of this joist. So again, I'm going to go ahead and edit that. Let me back out here. Let me do my multi-edit again so I get everything, all 4 of those joists to be the same. Okay, and the way I'd create an extension with the BIM joist, notice I have a setback option here, so this is going to work similar to beams. A positive setback is going to make that shorter, negative is going to make that longer. Remember, I have my left end, my right end. So I'll put a -3 on the left end, and on the right end, I'm going to do a -2 foot 0 to extend that over 2 feet. Okay, so there I get my extensions. Now, the way I did this here currently is that entire end, including the seat, is being extended. Now, maybe on this left end, it's getting the same thing. Maybe I just want that top chord extended and not the entire end. So what I would need to do for that, again, I'll go ahead and edit this. And in the edit window, I just have a checkbox for a full seat. So if I have that checked, that seat is going to be the same length as that entire end. I just want the top chord on this left end extended. So I go ahead and uncheck full seat process, and I should see that seat now does not extend the entire end there. Okay, so just a few different things here with that pre-configured panel layout. All that, as far as the extending the end and all that, could be done with the reserved space joist as well. I'm just kind of showing you here right now with the pre-configured panel layout. Okay, so let's go up here maybe to my roof, and I'm going to input some joists along this sloping roof here. So I'm going to come up here to my elevation 126.0 and get rid of these construction lines. going to go ahead and offset here from there. I'm going to offset that 5 feet. And I'm going to put some different size joists in along here. Again, remember these two beams that I'm framing between here are sloping. So again, what I'm going to do this time is I'm going to put the joist in with the bottom of the seat rather than at the top of the joist like I did down below. So remember, I use the offset controls. I want to clear that and hit F2 on my keyboard again to bring up the member type selection. I'm going to do my BIM joist. Again, I'm going to use intersection, construction line, and member. And I'm going to go with a 12K1 here this time. My bearing condition this time is going to be TC bearing. That'll put it at the bottom of my seat. I'm going to adjust my setbacks here so I get the correct setbacks. It's remembering what I did on the last joist that I had input or edited. Okay, so I can go ahead and input that, and I'll go ahead and just input that all the way along here. So one thing we're going to run into here now is we're probably going to notice that our joists are running into our beams a little bit. So we need to get a rotation on there so those are rotated correctly. So I'm just going to snap to the surface of this beam, and I'm going to go ahead and use my construction line add just to locate that member line, and my status line gives me the quick angle 6.5307 up here at the top. And I'm just going to go ahead and grab these, do a multi-edit on these joists. And what I have in here then is actually have the tilt option, so I can go ahead and put in my 65307. That's going to get those rotated for me then. And we really haven't looked at the connections yet. We're going to save the connections for a little bit later here. Now I can see how we get that rotated. Again, we'll come back to those connections after a bit. Just want to show us a few things here as far as the input goes. Okay. So next, I'm going to slide over here a little bit, and what I'm going to do is between the B_27 beam here and the B_77, I'm going to have some sloping joists, and I'm going to actually input these with a 5-inch seat depth on the left end and a 2.5-inch seat depth on the right end or the low end. So we can, just to show you how we might do that to get different seat depths. So I'm going to go back to this 107.8. I'm going to adjust my depth check a little bit so I can actually see my beam up here that I'm framing to. Get rid of those construction lines, and I will just add one 4 feet up here. Okay, so now again hit my F2. I'm going to do the BIM joist. I'm going to use my offset controls again because this time I'm going to actually input it at the top of the joist again. Depending on what you're doing, most of the time when you input these, input them at the top of the joist, and you're going to see probably the best results inputting at the top of the joist, and that's why I'm doing that most of the time here. So using my offset control here, 5 inches, intersection construction line and member. And then on the bottom end, I said I want 2.5, so I'll change my Z to 2.5 there for the offset. Intersection construction line and member again there. And this time I'm going to go with a 14K1 for my section size. And the second thing I want to do in here then, remember I said I was going to change the member end seat depth. So I can go ahead and change that to 5. On the right end, I'm going to leave that at 2.5. My bearing condition, I want that to be TC bearing flush, so I'm at the top of my joist. Zero my tilt out since it was remembering it from last time. And the other handy thing in here is notice we get inches per foot, the pitch that's on, so kind of handy there. Say OK. I think I forgot to check my pre-configured layout, so I'll edit that and change that to the pre-configured panel. And let's see what we got here. Okay, so here we got our sloping joists. We got a 5-inch seat up there on the left, 2.5-inch down here on the right. Now, one of the things you're going to notice, we probably have need to be bearing on that beam a little bit more. When you edit this joist, there are some checks that we do as far as, in this particular case, notice we get the red flag here with the warning about it's not meeting the SJI minimum bearing requirements. So again, I can maybe come in here and adjust my setback. So let's just go minus 1.5 to extend that out a little further. Process and create solids, and then I should get that over. And notice I'm bearing a little more there. If I edit that, in this particular case, that warning is going to go away because now we're meeting those minimum requirements. So you can also just copy these over just like you would any regular member. So now if I need to copy that up here in this bay, I can select my member, do a right-click, copy members. I'm going to do a linear copy. My Y spacing, I need 4 foot, and I want 3 copies. Okay, confirm that. And then I should have same thing for the joist going along there with my additional copies then. So one final thing I'm going to do here, and then we'll move on and look at some connections for these joists. I'm just going to go ahead and input 3 different joists over here, framing to some columns so that we have some column connections to look at here in a bit. So again, I'll do F2 with the BIM joist. I'm going to clear my setback and use exact point to snap to the tops of these columns. And I'm going to change the section size here again. Maybe I have a 24K4. Again, I want to input that at the top of the joist so the TC bearing flush. One thing you may have to watch out for in a case like this is you may have to watch out. Remember, I changed that standard, my member end seat depth. I may also need to adjust the standard seat depth, and the way I would do that is by changing that to a user connection, and I'm just going to set it to match the right side there also. Okay, and then I can go ahead and repeat this. And then I should just have the 3 BIM joists now framing to tops of my columns. There are a few odd things with this. You may have noticed I just did a repeat, and over here on these I'm not getting the pre-configured panel layout. Something we need to correct on our end. It's not remembering that checkbox there when you repeat. So just a few little things here and there that need to be worked out. Okay, there we go. Okay, so another thing that I'll mention here before we move on to looking at connections, one of the things that you may notice, if you have any joist girders that you need to input, there is no pre-configured layout for joist girders. Okay, all this information as far as the pre-configured panel layout, that's coming directly from Vulcraft. We can't change that at this point. There shouldn't be any need to. And there is no pre-configured layout for joist girders. There are certain other sizes also that don't have the pre-configured panel layout. So if I do select one of those sizes as I'm inputting my joist, I'm just going to go up here and in my section size, I'm going to type in there a 72G for a joist girder. And when I do that, notice it highlights those magenta, the 2 fields magenta. My OK button is grayed out because there is no pre-configured panel layout. So we are going to run into certain things like that. I'm going to go ahead and just cancel that so it doesn't save any of those changes. The other thing to take note of is if you're doing just the reserved space joist, That information can be modified. Notice I have a joist material file button up here in the upper right, and I'll show you where to get that here shortly. When I hit that, it's going to bring up a joist material file. This is completely separate from your regular material file editor at this point in time. But this is where the information for the reserved space joist comes from. Notice there's no information in here as far as your web material or your panel points or anything like that. So this is just basically specifying the top chord and bottom chord and your seat depths. You'll also notice in here some of these are not completely filled out. So like this 10K, if you were to input this 10K in the model, you're just going to get a member line. It wouldn't give you any solid information. Of course, you can actually edit this and input information in here, but by default, it's blank here for some of these, so you wouldn't necessarily see the solids generated. And you can come in here to edit this, or if you need to add something in here, right-click over here on the section size. You can copy, you can cut a row, copy a row, delete rows, so on and so forth. So the way you'd be adding or anything is by right-clicking over here in that row. Works a little bit differently than the regular material file editor. So, but that's where we would go to change the reserved space joist. Okay, so let's get into our connections a little bit. Up here in the upper right, one of the big things that we've done with the connections is there's actually a setup for these connections, kind of similar to a auto standard connection that we would have for beams, for example. We have that auto standard setup. This is going to work similar to that. So up here in the upper right, notice I have a joist setup. I already mentioned the joist material file. And just to show you where I got those buttons to put on my toolbar, if I go into the toolbar configuration, and in the command group, I would go down to Options, Fabricator Options, and then I need to scroll down about halfway or so, and I'm going to see the joist material file and the joist setup. I can go ahead and drag those onto my toolbar wherever I want those. Okay, so when I open the joist setup, first thing we're going to see is a setup name. Now, the joist setup is stored within the job, and then you also have a default setup files that you could load, or if you make changes, you can save off a setup file for the joist to load up in other projects. So this one's coming up with just the default setup. We have a manufacturer here. Now, even though there's a manufacturer specified here, and the only one we have currently is Vulcraft, you could actually use, you'd most likely probably want to use just the reserved space joist, but you could set this up to other joist manufacturers' standards as far as connections go, to use the connections of the BIM joist. Doesn't necessarily have to be with Vulcraft, even though that's the biggest player that we have as far as this goes, incorporated into SDS2 right now. Okay. Now, the next few options here are kind of just some default options. So the create full seat, we talked about that. In the edit window, we can tell it to create a bolted connection if the span is over 40 foot. Our bearing conditions, so when we're inputting those joists, what's the default bearing condition? For my purposes, I've been inputting at top of steel, so I may have wanted to come in here and change my setup to TC bearing flush. And then we have our supporting material hole type. So that would be if we're framing to the top flange of a beam and we're bolting to that beam, what do we want the hole type in the beam to be? I'm going to go ahead and change that to short slot. And then we get down into where we would actually specify kind of more closer to like the auto standard setup that I was talking about. So on the left-hand side, you have your framing condition. This would be a beam to column joist, beam to or top flange of a beam, framing to the bottom flange of a beam. We have column top, which would be framing to a column cap plate. and then column would be if you're framing kind of in the middle of a column somewhere where you're going to require a column seat. This is also set up per section size, so you'll notice we have the section size list of all the different joists over here on the right-hand side. So what I'm going to do is I'm going to select beam top flange, and if I wanted to change this for multiple joist sizes, I could do that at the same time just by holding Shift or Control to select multiple sizes. Okay. I just want to go ahead and do this for one joist right now, one size, and I'm going to change that for the 10K1. And remember, my framing condition is the beam top flange. I'll go ahead and select Edit over here on the right-hand side. And this is going to be split up into a couple different parts. On the left-hand side just shows us the framing condition and the section size that we're going to be modifying this for. We can override our seat depth and by checking that and telling it a specific seat depth we want there. The cap plate hole placement, that's basically going to be our edge distance, and I'll kind of show you this here after we get into the model a little bit. Now the connection to support, this is where I'm going to go ahead and set, in this particular case, how I want that to be connected. I'm going to go ahead and change that to bolted. We have our bolt type that we want to choose. The next section we have is for our stabilizer plate. So if I tell it to add a stabilizer plate, I can fill in the information for that. And on the right-hand side is for our column seat connection, if we were doing a column seat connection. So all I did here for the 10K1 was change this to be bolted. I'm going to go ahead and click OK. Click OK here. And I'm going to go through and I'm going to actually mark all of my BIM joists for processing. So just going to use my model tree over here to get all of my BIM joists. Now once I'm done processing, what you're going to see is we shouldn't see all of the joists get updated connections. The only ones that we should see get updated connections are going to be my 10K ones down here framing to these beams. Now, the reason why is because in that setup, I changed the beam to top, joist to beam top flange for 10K1 sizes only to be that bolted. So notice like I put in the 14K over here. That's not updating. The 12K is not updating either. So it's per framing condition and the section size. Okay, let me go back in there and into the joist setup again. Now what I want to do this time, I'm just going to go ahead and load a different setup file that I have. So if I use the load button down here in the bottom, I actually have a setup file here, the SJI Vulcraft setup. Now this isn't one that we specifically export, this isn't one we specifically distribute with SDS2. If this is something you would like, let me know. We can get it to you, or let your support rep know we can get this to you. But this is one that we've worked with SJI and Vulcraft to kind of come up with a standard for the connection. So I'm going to pick that option there. I'm going to hit open. Notice my setup name changes. And let's say I go in here and pick the 12K1 beam top flange and I edit that. Notice that connection to supported now is set to bolted. So it's having some different options there. Okay. I'm going to go ahead and click OK to this, and I'm going to go ahead and grab my BIM joists again, and I'm going to mark all those for processing and see what we get here now. Okay, so if I zoom in here and take a look now, should see we still get those bolted. That was set up the same. But now if I take a look over here, my 14Ks that I input are bolted. Should be bolted up here at the top as well. And I get the 12Ks bolted here also. If I take a look at the joist framing to the column, I now have a seated connection over here for that. I wasn't actually getting any connection over there for my 24K4s previously. So we're seeing more connections be generated here. That's essentially the setup for the connections. I'm not going to go through each one of those framing conditions. You guys got an idea of what options are in there, how to change those, how to modify those if you need, load new setups, that sort of stuff. So we have an idea of how to set those up. Now, let's take a look if we have certain conditions where we need to make changes. How do we make changes to just individual connections? Well, it's going to be done in the joist edit window. So again, if I just double click to edit that joist, you're going to see the different tabs up here for different connection information. So in this particular case, I'm looking at my column seat. So I'll go ahead and pick column seat. Everything is currently grayed out. If I do need to change something, go ahead and check that user connection option there. One of the things you'll notice is right now that angle seat is just welded to the column. We do have an option there if we check that to bolt that to the column instead. We can change the size, the width, all sorts of stuff there. We do also have, if you want different angle with a stiffener, just a T. Maybe you want to do a plate with a stiffener. When you do change that, watch out here. Notice all my values are zeroed out here currently, so I will need to go in here and change this. Maybe I want a 4-inch plate. Maybe I'm going to make it a 1/2 inch. Your stiffener, you can do rectangular or triangular. Again, fill out the width and the length. Maybe I'll do a 1/4 inch thickness. You have your weld sizes. Okay, so I'm going to go ahead and hit OK there. And we should see that seat change from the angle to my plate with a stiffener, which we do. Okay, notice my bolts kind of went away here. I'm going to snap to the surface and show you what happened there. Okay, when I input that seat, notice the holes in my seat are not lining up with the holes in my joist. So I'm going to go ahead and edit that again, and what we have is in the column seat, we have this joist gauge right now. It's at 1 5/8. If I go over to the seat connection and I look at my slot gauge of 3 1/4 there, I would need to get my joist gauge over here to match that so my holes line up. So go ahead and change that to 3 1/4. That's going to move my holes out so they line up with the holes in my joist. And there I get my bolts since everything lines up now. Okay, so just different options with the seat connections. Remember, you just have to check that user option, make sure your values are filled out to what they need to be to give you your seat options. So next thing we might want to look at, maybe instead of a seat there, I want a column cap plate. So let's drop this column down 2 1/2 inches. So I'll edit that column. I'm at 126.0 now. I'll go to 126.9 1/2. And just like I would a regular SDS2 joist, I'll change my connection type to auto base cap plate. I'll process and create solids. And what I'm going to actually see here is I'm not going to get a cap plate. Okay, there are currently some limitations with the way that custom members, the BIM joist is just simply a custom member. There are limitations with the way those interact with regular beam or column members to where the beam and column members can't always recognize those. This is one of those cases. So we can still get a connection here fairly easily, but what I might have to do is I might have to use the plate definition schedule and set up a plate in there. I'm just going to set up a simple cap plate here. So I'm going to copy what I already got in there. I'm going to change that piece mark to a CP1. I'll leave the thickness, but let's go 10 length, 10 width, and I'll zero out the hole information. So I'm just giving a square cap plate, no holes, set up in the plate definition schedule. Let's apply that to this column. Now when I process and create solids, what we're going to see happen is it goes ahead and puts that cat plate on there, but then it goes ahead and does the hole match in here and creates that so that I get my holes in that cat plate bolted to that joist. Now, one of the things that's real easy to change here, I'm just going to go ahead and add a construction line through the center of my holes in the cat plate. I can edit that joist and change those real quick, like real easy like. If I edit that, go into my, this time I'm going to go into the seat connection. We have that set up to be bolted, and down here I have the option for wide flange column cat plate. This does come from setup. There was a field in setup to change this, but let's just go ahead and say I want to increase that. Maybe I need to go 3 1/4 inches there. So I can change that, and we're going to see that hole in the cat plate move out. We are still lined up with our slot just enough, but we do, and we can see that. So easy to get that changed. Again, remember that is in the connection setup, so we could change that to whatever we needed in the connection setup. So some of these things you can kind of see. I'm trying to show some things where this gives an advantage over the regular SDS2 joist member, so that you may start using these. And just to kind of take that cat plate one step further, I'm going to go down here to where we have two joists framing to our column. And if I drop that down the 2 1/2 inches and apply my plate from the schedule again, it should go ahead and give me connections for both of those joists then. Okay. And we can see that. Now, moving on here a little bit, so we kind of see how we can set up the joist connections, see how we can modify those in the joist edit window. I want to kind of talk about just the stabilizer plates for just a minute here. My joist setup for my 24K4 was set up to add a stabilizer plate, so SDS2 automatically calculates that setback that we need there on the bottom chord. I can also change that in the joist edit window, and the way I would do that, I'm going to have to set that to a user connection in the member here, and I have a bottom chord setback. Say I just change that to 1'0". Just to point out, if you go to the stabilizer plate, you can change different information based on for each condition here in the joist edit window. I just changed my bottom chord setback. And what I want to point out to you here is even though my bottom chord is not extending to that stabilizer plate, since we have all that information and set up and it's putting that information in the joist edit window, I'm still getting that stabilizer plate even though I changed the setbacks to where it's not extending all the way to that plate. The other thing I want to point out to you here is that bottom chord setback is actually coming from the top chord setback, not the member endpoint. So if I offset this construction line from that bottom chord 1 foot, notice it goes to the where the top chord setback is rather than the member line, which is actually up here in the center. So just something else to keep in mind there. One other thing I want to show you with the stabilizer plate that kind of gives us, again, an advantage if we run into this situation over the regular SDS2 joist member is I'm going to go in here to 114.6, and I have some W18 beams here. I'm going to add a BIM joist here right along the midpoint of that. And I'm going to add in here a 20K4, so it's just a hair deeper than my W18 beam, adjust my setbacks and whatever else I might need to in here. My bearing condition, I want that TC bearing flush. I'll go ahead and do the pre-configured panel layout again. And what I should see here right now is I'm going to see this joist, and I kind of screwed up because I should have done my offset when I input this. Not a big deal. Let's just go ahead and move that up 2.5 inches. Okay, so I got my joist in here, and what I want to do is I'm going to go ahead and change this. I'm going to update the setup so that it extends there and gives me a stabilizer plate. So in my joist setup, go in here, I input a 20K4 and beam top flange. I'm going to edit that, and I'm going to say add a stabilizer plate. Let's go ahead and mark this for processing. And I did something wrong here, screwed something up. I have a 20K4. Let me check my setup one more time here. Beam top flange. That's a 20K4. If I edit that, I have stabilizer plate. Let's do bolted. Okay, okay. Let me just go ahead and re-input this joist quick. Add a construction line here. Let's just go right next to it. And this time, the way I'm going to do that, I'm going to do F2 for my BIM joist. Use my offset control and intersection construction line and member. I have TC bearing flush. We have 20K4. Not at a user connection. Okay, that's a little better. So what I see here is, this is what I wanted to point out with the stabilizer plate, where that gives us a bit of an advantage over the regular SDS2 joist member. If we were to do this with the regular joist member in this situation, we would get no stabilizer plate. With this situation, SDS2 and the BIM joist, it can go ahead and give us that welded to the bottom flange of our beam. So if we do run into something like that, again, the BIM joist can help us out with that, do that automatically. So, okay, so again, we talked about the pre-configured panel layout. We talked about the connections, and like I said, everything we've done up to this point really is kind of Vulcraft related, but like I said, go into your setup. If you want to use this, go into your setup, modify that to be other joist manufacturers' standards with the connections, and you can still use the reserved space joist to take advantage of some of these things with connections. Okay. One last thing I want to show you here before we end the webinar. I'm just going to do a quick demonstration of the BIM Joist Import. So this would actually be used if you are working with Vulcraft and you've communicated with them up front on the project that you want to take advantage of the BIM joist and importing the as fabricated joist from them. Okay, so you can communicate with them up front. They might want your just stick model where you've gone through and just input your beams, columns, braces. They wouldn't be too worried about getting connections right or miscellaneous steel at that point, but they could take advantage of that, your SDS2 model, in their detailing software to lay out everything. It's going to help them be more efficient and get things to you quicker. You'll get that information back that could help you out also. So I'm going to go ahead and just create a new project here. New fab, new job. And the files that I'm going to use, these are actually installed with SDS2. So if you guys later on want to do the same thing just to play with it, you can do that. So what I'm going to do here is I'm going to run a parametric, and this parametric is going to actually be located in your SDS2 data directory. If you go into the plugins folder, then into design data, members, joist, BIM joist, and test, there's going to be a basic training model parametric in there. When I run that, it's going to add a bunch of members here, pretty similar to our basic training model. It's going through the process and create solids right now after it added those. There's a few differences in this and the basic training model. You'll see some things missing. Okay, so now what I'm going to do is on your default toolbar, if you're using the SDS2 default toolbar, there's this BIM Joist Import over here on the right, kind of down towards the bottom. Okay, that's going to run the BIM Joist Import that you would use if you're receiving an XML file from Vulcraft. Okay, my operation up here, I want to create joists by location, so it's just going to import them at the location that they're at. And then I need to select the XML file. Again, this is one that's installed with SDS2, and if I go into my data directory, into that plugins folder again, design data, members, joist, BIM joist, test, and I have a Vulcraft basic training.xml in there. Select my XML. I'm going to uncheck the option there to create bridging, and the reason why is we typically find you get better results if you import the bridging separately from the joist. So I'm going to uncheck that and kind of do this in two parts. So go ahead and click OK here, and this is going to actually import joists that came from Vulcraft. They export this in an XML file. We've in this webinar so far to show you the pre-configured panel layout and the connections, I've always just done a regular parallel joist. When we do the import, we can see that we have some different shapes in there rather than just the parallel joist. We're going to see a pitched joist in here. We have an arced joist that can be imported as well. I guess I need to click OK to this window so it can process and create solids. The other thing to kind of take note of here is, and you're probably noticing, it definitely is not the fastest. I would say you're going to be efficient probably with up to 200 to 300 joists during the import. If there are more on the project, communicate with Vulcraft, see if they can't export those and get it split up for you a little bit into several files if you have to. So we're going to see here, once this gets so far in the process and create solids, notice we can start seeing those joists over there become solid. We can see those arced joists start to come in. Things like that always do take a little bit longer just because all the geometry and everything is a bit more complicated than with just a regular parallel joist. So now the other thing you'll notice, these do get imported as the BIM joist. So once it's imported, and I'll show you this, we can go through and we can edit these joists. There's going to be a couple things you want to watch out for and make sure you don't do here. So we got this imported. Like I said, we got the pitch joists over here. We got our arced joists. And then we just have some parallel joists. Now, what I want to show you is if I just snap to the surface of one of these here, and let me adjust my depth check a little bit. I'm just going to go in 5 feet. So, okay, so I got two joists there. I'm snapped to the surface. We can see they're using the same layout, all the same panel points and everything here being used. Now, if I edit just this one, it's going to bring up that same window that I'm used to seeing. One thing you're going to notice, however, is the pre-configured panel layout is not checked. Okay, That's because it is not a pre-configured panel layout. This came directly from Vulcraft. This is the as fabricated joist. This is how they would, exactly how they should be fabricating that. Now, I can still import, or excuse me, still check that, but what's going to happen is it's going to then override the information that I imported, which I don't want. Okay, when we do that, notice that material got bigger, my panel points are different, so it's not going to be exactly what they figured and what I imported from them. This kind of goes back to showing you also that the pre-configured panel layout uses kind of a worst case scenario where some of that material might be larger than what Vulcraft might design that with. So with the as fabricated ones, a lot of times you maybe get a little bit more efficient joist. But so just something to watch out for there. And last thing I'm going to do here, told you I was going to import the bridging as well, so I'm going to use that same BIM Joist Import button that I used. This time I'm going to tell it to import no joists. I'm going to go out, grab that same XML file. This time I'm going to leave the option to create the bridging checked, and I'm going to hit OK. And what this is going to do, using that same XML file, the bridging information is in there, and it's going to import all that bridging information from Vulcraft into my model. Okay, let me turn piece marks off here so it's a little bit clearer for you. And we can see all the bridging get imported then. So the bridging really at this point in time isn't a member that you're going to be able to edit, more just for a reference at this point in time so that we know where that bridging information is located. So that's what we have today for the webinar. So just want to thank everybody for attending. If you do have any questions on any of this stuff, please contact your support rep here at Design Data. They should be able to help you out. Again, thank you, and I hope everybody has a great day.